Newton's laws. So here we go. There's three basic laws of motion that were created by, or I can't say created by, quantified by, discovered by, described by, for the first time by Sir Isaac Newton in the mid-1600s. His first law, I guess before I get into the first laws, I should say this. Besides doing all that, Sir Isaac Newton also did a ton of work around optics and light. He invented calculus, just a minor little detail, invented calculus. I mean, Newton really is probably the biggest giant of a scientist that ever existed. Some of Albert Einstein's work, it conflicted with Newton's, and Albert Einstein's proved to be correct. But I think most would still say that the work that Isaac Newton did, it's been, no one else, it dwarfs everything else around him or any other work that's been done since or beforehand. Anyway, so his first law of motion is called inertia. We call it the law of inertia, and it's just, you've probably written it already, that a body in motion will stay in motion, or a body at rest will stay in rest unless acted upon by an outside force. And I think we have lots of good examples of that. The one that I have, two that I have written here are, we need seatbelts. We need seatbelts because when the car comes to a stop, your body, unless the seatbelt acts on it, it's going to stay in motion, right? And that's why that's inertia, right? A second one is if you've ever driven around the highway, and I know that you have, and you sort of feel yourself pulled to the outside of your car, leaning against, if you're the passenger seat, right? You get sort of pulled into the door. And the reason is inertia. Your body's still heading in a straight line, but the car's turning, and so you're kind of running into the car door is what's happening. And the outside force that causes you to turn the corner, of course, is the car door pushing you. Okay? So that's inertia. The second law is what I call the math law. And here's the math of it, F equals ma. Force equals mass times acceleration. And what it means is more force means more acceleration, and more mass equals less acceleration with the same force. It's in the second law that we do most of the math of this unit. And it's really just this equation. Again, if I'm going too fast, please pause. But my examples of Newton's second law is if you ran up to Johnson and had a certain amount of force, say all the force you've got is everything you can, and you run into him, you probably won't be able to push him at all. But if you can, it won't be very far. Right, Mr. Randy Johnson? But if you run up to Miss Hillary, poor Miss Hillary, with all your force and all your might, she'll go flying. And why is that? Because she's small, he's big. Big mass, little mass, right? And that really speaks to this, right? More mass equals less acceleration. And you could quantify that, put a calculation to it with the equation. And another example might be if two of you with the same amount of force pushed as hard as you could on Mr. Johnson, you could get him to move further than if just one of you did, right? So that equation, F equals ma or F net equals ma, just wanted to give you a little bit of, I don't know if you ever use the triangle. I'm not a huge fan of the triangle, but I do know that some people find it helpful. If this is the basic form of the equation, F net force on an object is mass times acceleration. If you're looking for, though, acceleration, you use the triangle by covering up the a, right? And a equals F net over m, right here. And if you're looking for m equals F net over a, or if you're looking for F net, equals ma. So however you want to use, if you want to use it the triangle, if you want to use the three forms of the equation, one of those are going to have to go on your formula sheet. Okay. Important notes: a is meters per second squared, m is kilograms, and F net is newtons. If I'm going too fast, please pause and get writing. The third law is what I call the karma law: do unto others as you would have done unto you. Every force has an equal and opposite reaction force. There's lots of examples of it. The one, if you look up on my blackboard, you'll see the poster of the guy jumping in the pool, the jerk in the pool. His force is his butt on the water, and the reaction force is the water back up on his butt, but also on everybody else. The example that's sort of easier, you run into a desk and you stub your toe, right? And obviously you apply a force to the desk by running your toe into it, but your toe hurts afterwards, and your toe hurts afterwards because the desk also applied a force onto your toe. And that's the idea of action and reaction force. Okay, that's it for Newton's laws. That's today's video. Just make sure you get it all down. There's some great activities. I'm going to show you in class some of the videos that kids have made, which is a great thing you can do as a group for one of your assignment options. Yeah, that's it.